Imagine you are taking a road trip down a very strange highway. Every single town you drive through has exactly one rule. They either pay you cash just for showing up, or they charge you a hefty toll before you can leave. Take a look at this map to see our route. We have 4 towns. Town A pays you $4. Town B charges a $1 toll. Town C pays out $2, and Town D hits you with a brutal $6 fee. Your goal is simple. You want to identify the single continuous stretch of this highway that leaves you with the absolute most money in your pocket. Finding that perfect, unbroken window is pretty easy when you only have 4 towns to consider. You can probably spot it right now. But if you are planning a trip with millions of stops, finding the most profitable route becomes a massive mathematical puzzle. This diagram shows the standard way a computer tries to solve that puzzle. It relies on checking every single possible start and end point. You calculate Town 1 to Town 2, then Town 1 to Town 3, then 2 to 4. It requires mapping out dozens of overlapping brackets and recalculating old routes just to find the highest total. Now, imagine finding that absolute perfect stretch by driving the route exactly once, and never once looking in your rearview mirror. That specific one-pass shortcut is known as Kadane's algorithm. It is a logic trick that completely solves this problem without any of the overlapping chaos. To make this one-pass drive work, you only need to keep track of 2 numbers on a mental notepad. Rule 1 is your current wallet. This is simply the running total of the money you have made on your current unbroken streak of driving. Rule 2 is your high score. You can think of this as a permanent lockbox for the absolute highest balance your wallet has ever reached at any point on the trip. By updating these 2 numbers sequentially at every single town, you guarantee that you will never lose track of your best streak, even if you keep driving. This dashboard shows how the logic plays out in real time. We pull into Town 1, which hands us $4. Because it is our first stop, both the current wallet and the high score are set to 4. Notice on the screen what happens when we move to Town 2, the $1 toll. Your current wallet ticks down to $3, but the high score safely remains locked at 4. We don't stop our driving streak here, because $3 is still a positive balance. We can build momentum from it. Watch what happens here at Town 3, which pays $2. That gets added to our streak, boosting the current wallet to $5. Because 5 is greater than 4, the high score counter flashes and locks in a brand new peak of 5. Looking at the dashboard now, we hit Town 4, the massive $6 toll. This disastrous stop drains our entire wallet, plunging our running balance into the red at -$1. Focus right here on the negative balance. The exact moment your running streak drops below 0 is the critical decision point for the entire trip. There is exactly one rule you need to make this work. An unbroken driving streak that puts you in debt is actively hurting your trip. Think about the logic. If the very next town on your route hands you $10, using $1 of that fresh cash to pay off old road trip debt is completely counterproductive. You are better off starting your trip from scratch at the $10 town. So you declare road trip bankruptcy. On screen, we literally slice off that negative baggage, reset the current wallet to 0, and prepare to start fresh at the next stop. Because the high score of $5 is safely locked away in its own box, declaring bankruptcy on a bad streak never accidentally erases the memory of the best part of the trip. Watch how this map smoothly morphs. The road straightens out, brackets cap the ends, and our towns turn into a formal list of numbers. In computer science, this structure is called an array. Your task of finding the most profitable stretch of road is actually the classic programming challenge known as finding the maximum subarray sum. The term contiguous subarray is exactly what we just found. It simply means an unbroken slice of the list, functioning identically to an unbroken stretch of highway. Mapping this technical vocabulary directly back to a tangible road trip demystifies a concept that trips up thousands of people during coding interviews. Remember that the standard brute force method wastes massive amounts of processing power, constantly looking backward to recheck overlapping combinations. Notice how this beam of light moves. Instead of pausing and looking back, Kadane's algorithm makes a single continuous forward sweep. Dropping the negative baggage and securely tracking a high score allows the computer to solve the entire problem in one extremely fast pass. That is the complete pattern. You move forward, add it up, drop the negatives to start fresh, and always keep the highest score safe.